Hello, it's David. Now, firstly, apologies for the voice. I've got a bit of a cold and, well, I do sound quite terrible. What's the difference, you may ask? Anyway, not the point. This is quite an exciting video for me. This is my original Falcon, as you may know, from 1993. I believe I got this. It still has the cellophane over the logo, you might note. And ever since I've owned this, I've done lots of things with this. I've had various different floppy disks in here, floppy drives. I've got a Gotek in here now. I've had SD cards, and there's actually an SPI interface hidden away under there in my DFB1 expansion. This has had a lot of work done to it, but it has only ever had an IDE hard disk. Well, I mean, it's had, you know, an actual hard disk. It originally came with, I think, an 80 megabyte 2.5-inch laptop size one. I remember at university I replaced the floppy disk with a second-hand 3.5-inch IDE. I think it's probably about 2 gigabytes that fell into my hands. I replaced that, and so I ended up hacking a lump out of the case here, genuinely hacking it with a pair of pliers or something, I think, to run the floppy and the floppy ribbon cable extension out, and the floppy would sit on top. Later I added a CD-ROM. I had a CD-ROM sat on the top here with the floppy on top of that. So this has had a lot of storage options with it, but one thing that it has never had is possibly the most widespread format of the time. I've never had a SCSI drive attached to this. Now this is for two primary reasons. One, IDE kind of was the end of SCSI, not in every particular walk of life, but in many of the home end certainly. And also secondly, this was a rather unusual connector. This is a 50-pin high density D style SCSI2 connector with clips on the side rather than your normal screws to attach to, and it is a standard. However, it's very difficult to find things that fit this. The Macintosh, for example, used DB25s. The later SCSI variants used these HD 68 pins, which you can still find rather more commonly. But so finding something to plug in there was always very difficult. And again, what was the need? But when I was working on my accelerator, the DFB1 that is in here, I obviously couldn't test the SCSI port, and we did have some feedback that there were problems with the TT RAM, the external memory, the fast memory if you like, and the SCSI port, mostly because of the choice of drivers. HD driver doesn't support it natively on the Falcon, for example. But I was unable to test all this, so I've always had my eye open for something that I could put on the SCSI port just to test it. And finally, here we go. This is a BlueSCSI2. Now this is a kit form that I've bought from Flame Lily Co. UK, and it comes virtually fully assembled here. The DB25, that will need attaching, and I need to put some headers in for a Raspberry Pi Pico. The version 2, by the way, uses the Pi Pico. I think the version 1 was an STM32, maybe a Blue Pill or something like that device. But yeah, look at this. This is, I think, the printed time of £32 I paid for this. It comes with all of these components. There's no way I could build this, the board, and source the components for a one-off build cheaper than that. So this just made sense to get a partially built version. And I'm going to solder it up. But wait, you say, that's the DB25 that you were talking about, and that's true, yes. This is intended for the Mac, the little form factor desktop Macs had a DB25 female on the back, and this plugs into that, and it actually draws its power from the termination resistors, so it doesn't need anything external. Not sure if that's true with the Falcon, but that's the sort of thing we're going to find out. But how can that work? Well, this is the bit that has caused me to actually go out and buy one of these. I have finally got my hands on an adapter. This is, I bet you've never seen this, unless you've got a Falcon and you used Cubase, which required SCSI. I bet you've never seen one of these plugs. This is the HD50D connector with the sprung-loaded clips that mate with that bizarre looking socket on the back, and it goes to a DB25, and I'm hoping, although I don't actually know, that this is in the right configuration so that it appears to be a Mac, and hopefully will work. Now this is not ideal. If we join all these together, this is going to hang a long way out the back of my Falcon, but at the moment it's just about getting it working, and if this turns out to be viable and interesting product, then I might look at some kind of either right angle connector on here, or doing my own version with actually one of these high density 50 pin connectors, if I could ever find a PCB mount one. I think I found one somewhere. It may have been on Mouser, but I obviously it was quite expensive, and because they're very, very unusual. But then I might be able to spin a board that does that. So we'll see. That's maybe one for the future. Now I understand that this should work basically with HD driver, which is what I use. Probably work with Emutos, which is the other operating system I use, or the other hard disk driver I use, I should say, is built into the operating system. And I believe there's actually a chance that this could, with a Dynaport driver, I want to say, I may be misremembering that, work with the Wi-Fi Pico to actually present as a network card. So that would be very interesting. So first things first, let's get this fully built up, and then we can have a play with it. And yes, this is a sticker. Lovely. Okay, so I've got my bits and pieces together. Fortunately, I managed to find some pin headers from an old, I think it was a Blue Pill STM32 device, because bizarrely I've completely run out of single pin headers. So that's needed for this PKW here that I've got. I blocked the holes there because I use that on a different project. I found 2 socket strips. There was one option that is available, obviously, is to solder these directly in here, solder the Pico on top, so the holes aren't clear, so this won't go through. And obviously this gives you a much lower profile device, but given my propensity to blow things up, I think it's prudent to add the sockets. It's only 2 extra rows more of soldering. So that's my plan. So I think let's just get on with it. Just going to take a couple of these perf boards and stack them up to get my pin alignment. Some people say use a breadboard. One, I don't have any breadboards easily to hand, but 2, I don't want to heat damage the breadboard, to be honest. So we'll stack up a couple of these. So they're all just stacked up like that. Hold it up in the air for me while I go down the lines. There we go. What do we think? Pretty smart design. And in case you were wondering, that's what the entire ungodly assembly looks like. And well, my desk isn't deep enough to actually have that hanging out the back of my Falcon full time, but I'm just intrigued to see if I can get something to work.
It's time once again for me to mention my friends at PCBWay. Not only are they the one-stop shop for your prototype PCB manufacturing needs, but they also offer CNC machining, sheet metal fabrication, 3D printing, and even injection moulding, all with an easy-to-use web interface. They have a module store, and they host shared community projects too. You can find some of my designs available for download or turnkey manufacture here, for example. Frequently you'll find discounts or vouchers or competitions being run, so if there's really anything you need in the maker realm, why not add PCBWay to your list of potential suppliers? So many thanks to PCBWay, and let's get back to the business in hand.
Okay, so the Falcon's booted up here just to double check that my configuration is working fine. This is just using the normal internal IDE drive. Absolutely happy with that. But what I'm actually going to do, let's just turn that off. I'm going to remove my IDE SD card. This is my normal little booting card here. I'm going to take that out so that we don't have a drive in the system. Power that back on. And this should now, there's no floppy, there's no hard disk. This should just boot straight through to the TOS 4.04 desktop. There we go, and that's obviously scrambled because I've got DSTP1 enabled on here, and the TT RAM is not accessible by the blitter. So actually what I'll do, let's turn that off, let's switch that over to emuTOS. There we go, perfect. So now we should have test configuration. Yep, there we go, loads of memory, but no disks available. Right, good. The whole point of that is just to get the hard disk drivers for emuTOS available to me, and not have it confused with anything that might be soft loaded. Okay, so the next step is to flash our Raspberry Pi Pico here that we've soldered up. And so to do that, we'll go to the BlueSCSI GitHub page. We'll select releases. I can see that there's one here. In this particular case, it was released on the 26th of October 2024. And I want to download the UF2. Okay, so here's my Raspberry Pi Pico. We'll hold down the programming button and plug in the micro USB. No signs of anything there, but I think that's normal. Okay, and there we go. Removable medium is inserted, has appeared here. Open in File Manager. Well, we can do, won't hurt. And there you go. You've got index info Raspberry Pi 2. That's fine. So the UF2 file I downloaded. It should be here in. Oops, didn't mean to click that. So the UF2 file I've downloaded should be here in my downloads directory. There we go. So I'm going to copy that UF2 file to wherever it's gone. RP2. Copy that to there. And what should happen is that this mounted, or rather, pluggable directory there should disappear. There, a drive was removed without ejecting. Yeah, that's how that works. We've now got ourselves a green flashing light on the Pico. Excellent. That's it. Let's plug that in. So Pico goes, pin 1 is there. Pin 1 is there. That way around. Do believe that's correct. Pin 1 is there. That's the square pin. Pin 1 is there. Yep, there we go. And that's the slot there for the SD card. But that's now ready. So we can try putting my IDE SD card that I just took out in there.
but because of a problem with my auto byte swapping adapter at the moment, i.e. I blew it up. This is in original Atari byte order format, and so it may not work on this, but we can give it a quick try and see. Okay, so we'll try and slot that into the back of the Falcon. It's well, it's incredibly unwieldy at the moment, I'll be honest with you. Click, click. There we go, I heard that go in. Now, I don't believe this requires any external power because it draws it from the termination voltage that the Falcon applies. But we'll have a look, because basically that green light, I think, should start flashing when we power this up. Okay, power is on the Falcon. Green flashing light, that's a good sign. Okay, I can see Emutos is booting on the screen. I'm just watching this light at the moment. Okay, that's not recognised anything. Okay, so Emutos has picked up that we're on a Falcon with 14 megabytes of ST RAM and 128 megabytes of TT RAM, which is the normal DFB1 configuration. But it's only showing drive A. So yes, that could very well be the problem with the byte order of that card, or perhaps it doesn't like the partition table. So I think what we'll do is we'll try my ST hard disk. This is the one that I use on, it's just about got STE written on there. So this is the one I use on my FM, STE, and on the Mega when I've got an ACSI drive. But what it won't do is it won't have any byte swap issues because they are all 8-bit interfaces. Let's see if this is any better. Ah! Oh ho ho! That's probably what that was then. Here we go. So this should be my ST drive, which will have something like, yeah, Day of the Tentacle, which is my normal test on the ST. Let's just put ourselves into high res, because we can, into high colour I mean, and let's try and Day of the Tentacle. Ah, this is all happening off the SCSI. This is the BlueSCSI. It's the first well, it's the first data transfer we've got. I don't think I've ever tried this on my Falcon before. Be interesting how the DMA sounds work.
I'm thirsty.
Oh, not bad.
I don't think you should drink that.
Because obviously STE designed.
It looks bad for you.
And I think...
Nonsense. It makes me feel great.
I've got a feeling the 0 point is
More
different
aggressive.
between the Falcon and STE on the samples.
I feel like I could. Like I could. Like I could. Take on the world.
Okay, so a couple of things have happened. I've gone away and read the manual, which is a little bit unusual for me, I appreciate. And it turns out that actually slapping an existing hard disk image into the SD slot is not the normal way of doing this. You actually you put a FAT32 partition on there, and then you supply images within inside that. Actually, it says exFAT is recommended, because presumably you can break the 2 gigabyte barrier there. But anyway, FAT32 is also fine, and it's got a naming convention and things like this. So fine, I have set that up. But for the Wi-Fi, here we go, Wi-Fi Dana port. What we have to do is to provide an INI file, or a pair of INI files. So one called BlueSCSI INI with your Wi-Fi credentials in it, and another one, oh, here we go. Create another new text file and rename it to any4.hca. The 4 stands for SCSI ID 4. So that's an empty file, but we just pop that in there as well. So fine. So what I've got here, here's my BlueSCSI INI with where I would put my credentials. These are not there, so I shall update that shortly. I've gone with any 6, could use any 4. I figure that the I think number 7 is the SCSI controller, so 6 is just the next one down. And I've had a go at putting a hard disk image in here. This is actually, there's nothing, it's just empty, because I don't have anything to create a hard disk image here. But I thought I'd add it so we can test that later on. So HD 1, that means that it's SCSI ID 1, and 0, the LUN, yeah, which has to be 0, apparently, that's all that's supported. I forgot I had to actually go and set the correct credentials in the in that BlueSCSI, so I've just loaded that back in and have done that. Throw the switch. Can see a white light on there. Okay, and we're booting up. Just hold that for a second. There we go. Emulation 1.3, 128 megs of alt RAM, and drives up to J. Okay, and I'll switch to boot from my Mint drive, which is, oh, I forgot, official 1.3 doesn't give you the prompt unless you call boot. There we go, right, so drive G. So that's my Mint drive. And I've put the Dana port Wi-Fi SCSI driver into my Mint directory, and I'll link the website down below where I got that. That's from Anodyne Software, and that is, I believe Anodyne Software is at least in part Roger Burrows, who was the lead on Emutos for a long time. And we're not booting up. It's frozen. That's strange. I wonder if that's the BlueSCSI. Or if it's that Dana point driver. Oh. FF A0. Okay, so what I've done now is I've actually disabled the onboard flash with my DFB1 accelerator, so we're using the standard TOS 4.04 ROM built into the Falcon. My accelerator is still enabled otherwise, and I've put the SD card with the network configuration back into the BlueSCSI. So we're going to boot up into HD driver. A load of stuff flew up the screen there, I didn't quite see that in time. This is just booting to drive C at the moment to initialize the NV RAM. Okay, now I'm going to cold boot again, and we'll boot from drive G, which is my Mint drive. Back through G, yeah, no device. Dynapoint, I just saw it fly up the screen there, the Dynaport, sorry, network card driver, that was promising. EN0, there we go, we've got ourselves a network card. Okay, right, let's set this up. Got to remember my fconfig commands now. This is very old sort of NetBSD style one, I think. 2255, there we go, root, and it's accepted all that. $55 packets in. Ho ho! Beautiful! Look at that! Let's see, I'll tell you what I'm going to do. I'm going to run something in the background just so that we can see if it's frozen, because I think I've read somewhere in the instructions for the driver that polls, so it might lock up things. I think it couldn't do background disk access or something. Can't remember. Anyway, we'll have a look. Right, so let's connect to an old FTP site. There we go. I'm just looking for something of a reasonable size. So what's Okay, this is 672K. Herm116C, let's get that. So we want to go to bin mode, we'll tell our hash printing, get Herm116C LZH. Aha, yes, and look, lines have stopped at the top. Oh no, actually it's come back. Oh, we've only got a little bit. That's a pity. Maybe let me try a local FTP site. ZX SP207 zip. That initial freeze again, we get a block of data. Oh, got a bit more this time. But yeah, it's there we go. You see, when it's running, there's no background processes. Oh, very few anyway. Is that finished? It's not printing a summary, but it's moved to a new line. Huh. Okay, so this is using wget to a local machine to download the Emutos zip that I downloaded a few minutes ago, and this will actually give me a throughput counter. So yeah, there we go. Look, we're getting sort of like 15 to 18 kilobytes per second. Okay, so there we go. Ultimately, we averaged about 14.5 kilobytes per second, which is about 115, 116 kilobits per second. So that is pretty poor, thinking about it, because I used to be able to get 56k bits per second on the serial alone, and it does do, in theory, 115k, but it does struggle to keep up with that. So actually, we are talking serial-like speeds here on the Wi-Fi. So it's probably not going to replace my Ethernet, but I think what it probably ought to do is to get that out and test that against this before we finish up. Let's see whether I can load anything with cab or iWire. It's having a go. Yeah, we're transferring some data. There we go. Google kind of works. Do I have images turned off or something? Oh, there we go. Yeah, 54k that was getting. Yeah, it is like super serial speed. But there we are. Google, it is here. it does kind of half work. I think this normally fails because it immediately wants to go to HTTPS. Something's happening. How about that? Good old Google, still just about supporting the just about supporting the old browsers. Okay, so I put a 512 megabyte partition image on the BlueSCSI there, and I've formatted that with where are we? Yeah, here we go with the BlueSCSI, and I've formatted that there, or partitioned it, I should say, with HD driver here, and you can see there we go. It's picked up the Dana link. That's on there as well. So there we go. And what I've done is I've copied some files on and off it just to prove that it works. One thing that you do have to be careful of, if it's fine if you're using Emutos, but if you're using HD driver, you do need, sorry, not that one, you do need to apply this AB40 fix here, and this basically mentions DFB1. Uwe's updated this. This was not present until the late HD driver 11. Probably HD driver 11.10 onwards, I guess, somewhere around there. So this was obviously originally intended for the Afterburner 40, which had the same problem, where SCSI can't talk to the fast RAM, and it's the same with DFB1. I think he must have something built in to cope with the CT2 and CT60 because they have exactly the same limitation. So I don't know why they don't require this. But anyway, you have to pop this at the start of your auto folder, and then it works absolutely fine. Anyway, so we can open up drive K, not on my desktop. There we go, I've copied Doom on here, and we can fire that up, no trouble at all. And there we go, that's normal because it's I'm in 256 colour mode here. It messes all the palette up when it renders into the window. And there we go, yep. That's Doom, we've seen that. Right, so let's have a little bit of a measure of the throughput again. So get the old throughput tester out here. Medium or high res, oh gosh, really? Okay. So there we are, right, find an SD high, alright, and we're going to go for a combined read-write test, transfer rates, quick test. Now remember, this is on an accelerated Falcon, so it would probably be slow without it. Right, but there we go. We're getting about 1.8 megabytes per second read speed, and a much slower 268 write speed. I'm only looking at the long files. Okay, 1700, 300. Yep, 1700, 300, that sort of range. And for comparison, I think we've run this already, but this is, oh, I didn't mean it there. That's the simple read test, I think. Let's do that again, combined test. Yep. This is for drive C, which is the ID. There we go, look, we're getting 2.5 plays 2.5 read, plays 2.1 write. So okay, the IDE is with the accelerated CPU certainly is still a lot quicker. Okay, so the other thing I've done is that I've hooked up my Hydra, which is basically it's the precursor to NetUSB, and it is the successor to the Ethernet adapter. So I've got this in the cartridge port here, and at the same time as having the BlueSCSI here in the back of the machine. So we can do a side-by-side comparison here on the Falcon. So what I'm going to do is download a standard test file, which is the emulation 1.3 zip with both mechanisms. So if we look at our if config, we can see we've got EN0 and NE0. EN0 is our Dynaport emulator, the BlueSCSI, and NE0 is the the Hydra Ethernet emulator. So what we'll do, first of all, let's set up our Dynalink again. Okay, so this is our standard candle. This is emutos 1.3.zip. It's the 512K version. I've just renamed it for brevity. And there we go. It's 3.4 megabytes long. We're getting about 17 kilobytes per second. We'll just let that run through and take the final total. Okay, well, I let it finish, but I was really losing the will to live there. It even stalled at one point, and I had to do a continuation get. So 16.6 kilobytes per second translates to about 130, 132 kilobits per second, which, to be honest, is not any better. Well, no, it's a little bit better than you can get with a serial, but with this accelerated Falcon, I would honestly expect to be able to service 115 kilobit serial interface, which the Falcon does have on board, two of them actually. I would expect to be able to service that at basically full speed, so I think we would be getting maybe like 2/3, 3/4 of this speed, of this performance with serial alone. So to be honest, that's pretty bad. Right, so what we'll do now is we will take down that network interface, and we'll use exactly the same setup command, but for NE0, which is the Ethernet interface, and then the same with the root. NE0, there we go. Right, and we can now run that same wget without the C. This is now using the Hydra And this, by the way, is now real time. Okay, so 277. So we're looking at something in the region of 2 megabit. That's a lot better. So there it is. That is the BlueSCSI. I must say I'm thoroughly impressed with the hardware, with the sales setup that they have going on, and its capabilities. But it's just not really a frontline solution. I think in the modern world there are better options available these days for basically what it does. That's for the Falcon. This does have a lot of other tricks up its sleeve. Obviously this was originally intended for use on the Mac, but this actually works in a sort of a host mode as well. You can plug up an actual hard disk into here, and this will image it onto SD card for you in acting as a host mode. So this has a lot more tricks up its sleeve than I've shown today, but for what I was hoping to use it for, I think it's an interesting little toy. The fact that it's Wi-Fi is great, but ultimately it's not really going to replace what I already have, and if I do want a Wi-Fi solution, I think I'm still looking. Anyway, thank you very much for watching, and I'll see you in the next one.